Hello everyone, this is C.S. Lalita Bharati from 2nd MBCS. Today we are going to learn about op-amp. Op-amp. Op-amp means operational amplifier. An operational amplifier is a DC coupled high gain electronic voltage amplifier with a differential input and usually a single ended output. And this was the circuit diagram of the op-amp. In this we can see non-inverting, inverting, output. In this non-inverting means we should take positive voltage, and inverting means we have to take negative voltage. And going to op-amp parameters, we have 8 types. In that, first one is of input offset voltage. Second one, input offset current. Third one, common mode rejection ratio. And fourth one, output offset voltage. Fifth one, slew rate. Sixth one, output voltage swing. Seventh one, input bias current. Eighth one, and finally eighth one, open loop voltage gain. And going to the topic, first one is input offset voltage. When two input terminals of the op-amp are grounded, ideally the voltage must be 0. But practically, op-amp produces the small output voltage. To nullify the, the voltage, same voltage is required to be applied to either to the two inputs. Such voltage is called input offset voltage. And this was the circuit diagram of the input offset voltage. Second one, input offset current. The two input terminals of the op-amp are two base terminals of transistors Q1 and Q2. The input currents of the op-amp are base currents of the transistors Q1 and Q2. Ideally, Q1 and Q2 must be perfectly matched and hence base current must be equal to 0. But the base current differs by a small change which is called input offset current. And this was the circuit diagram of the input offset current. Third one, common mode rejection ratio. When the same input voltage is applied to both input terminals of an op-amp, the op-amp is said to be operating in a common mode configuration. The relation between differential voltage gain to be common mode rejection, the common mode gain is known as common mode rejection ratio. Therefore, common mode rejection ratio is equals to AD by AC, where AD is equals to differential gain and AC is equals to common mode gain. And the ratio indicates the ability of the op-amp with which the common mode signal is being rejected. Common mode voltage is obtained by following circuit. Okay, where Vs is equals to common mode signal applied to both the inputs. Here Vout is equals to output voltage. Fourth one, output offset voltage. The voltage present at the output without any input applied applied is called output offset voltage. And this was the output offset voltage. Here we are connecting the input to the ground. Fifth one, slew rate. The maximum rate of the output voltage with respect to time when the input is changed is defined as slew rate. Therefore, S is equals to dV0 by dt maximum. Sixth one, output voltage swing. The output of the op-amp is limited and it depends upon two inputs and supply voltages. The limits of output voltages are plus VCC and minus VEE. Other than above voltage, that is more than plus VCC and minus VEE, the output gets saturated. For IC 741, op-amp plus V saturated and minus V saturated are plus 13 volts and minus 13 volts, or plus 15 volts or minus 15 volts. Seventh one, input bias current. It is the average of the base current entering into the input terminals of an op-amp is called as input bias current. And this was the circuit diagram of the input bias current. For IC 741 op-amp, the value of input bias current is 500 nanoamperes. Eighth one, and finally open loop voltage gain, and this was the circuit diagram of the open loop voltage gain. Here V1 and V2 are the inputs, and we are having integrated circuit and non-integrated, and V out means output voltage. It indicates that there is no feedback connect in this circuit. Practically, the value of AOL is 10 power 5 to 10 power 6. Thank you.